exam point of view, so that you can use that for your with visible. Sorry, hope it's visible now.
Yes,
Ah,
yes,
yes, sir, visible, sir.
yes, sir.
Okay. So just like class notes, this may be very easy to remember and reproduce in your exam. So this is not an elaborate one like what she has prepared, but few points that you can remember. Blood components, we can divide them into cellular components. That means what are all the cell content in the blood, which is packed red blood cells or red cell concentrate. And this red cell concentrate will have some WBCs also. So if you want to remove those WBCs, white cells, then you call it as leukocyte reduced red blood cells. In some conditions, the leukocytes may cause problem, like what is called the host versus graft disease. So that is in cases where you want to avoid that reaction, you have to remove the white blood cells also and give pure red cells. Then it is called the leukocyte reduced red cell. Then, of course, platelet is another cellular component in the blood that also you can separate it out. And when you take the platelet, again, you can have the normal platelet concentrate will have some WBC also. So that also can be removed and you can have a very pure platelet concentrate. And you can make even the subdivisions of white blood cells, as what she said, which is mainly used for bone marrow transplant people. So oncology people use it much more to give the immune component of that. So these are all the various cellular components that can be identified or prepared from the blood. The other half is the plasma component, and all of us are very, very familiar with fresh frozen plasma. And there is another category called single donor plasma, that is taking the plasma only from a single donor. And you can separate this into cryoprecipitate by spinning, and you can make cryo poor plasma also. And then there are plasma derivatives like albumin, which is 5% and 25%. And of course, what we mentioned about antithrombin and other smaller constituents of the plasma, which are not necessarily needed for your theory answer paper. Then there are plasma protein fractions, which are factor 8 concentrate like immunoglobulins, which are sometimes the IV immunoglobulins we do use for some neurological problems. And so that may be of use. And fibrinogen, other coagulation factors are also separated, especially as I told in DAC, we have to have a minimum fibrinogen concentration for adequate clotting. And preparation of blood components is possible due to how we are able to do it. Earlier in the olden day blood bank, you will get only whole blood all the time. If at all you want, you can separate that plasma and get packed red blood cells made immediately. But the system of separating the components was started only about 30 years ago. So the multiple plastic bag system and refrigerated centrifuge, different specific gravity of cellular components, and all these factors made only the blood component separations possible. So we have multiple plastic bag system. There is a refrigerated centrifuge available, machines are available, and because each cell has got a different specific gravity, when you spin them, they settle down at various speeds. So light spin, fast spin is the method by which we separate them. So red cell specific gravity is 1.08 to 1.9. Platelets are slightly lesser than that, and plasma is still more lesser. So because of the different specific gravity, we are able to separate them. And coming to what equipments we need for separating this, we need a freezer which can go from -40 to -70 degrees, and there should be a blood tank with a refrigerator of 2 to 6 degrees. And refrigerated centrifuge with a swing out head and the oval cups should be available. Laminar flow, weighing scale, dielectric sealer, aluminum clips and sealers, stripper, water bath, and platelet agitator, sterile docking device. These are all the equipment that you will find in a well-equipped blood bank for separation of blood products. Now, how do they prepare all these things? There are various methods, what is called gravity separation. As I said earlier, because they have different specific gravity, you can do it by gravity separation. You can do by low and high speed centrifugation or apheresis by cell separator. These are the three methods by which you can separate the components in the blood. Now, what precautions have to be taken in collecting a blood? Proper selection of donor, clean antiseptic site for veniculture, uninterrupted flow of blood should be there once you puncture the vein, and the correct amount of blood. Don't exsanguinate the patient. An automatic mixing of blood during collection should be there, and separate platelets within 6 to 8 hours. That is very important. If you want good acting platelets, it should be separated within 6 to 8 hours. Otherwise, it will disintegrate because it is a non-nucleated cell, so they cannot last long. And triple pack and quad pack systems are there, which can hold different components in the different way. And other precautions continuing are in centrifugation, balancing and use of rubber disc. Broadside of the bag faces the outside wall of the cup. Correct speed and time to be maintained, and look for any abnormal vibration. And preparation of packed red blood cells. RBCs are obtained by removal of supernatant plasma from centrifuged whole blood. So by light spin, you can separate the red cells and other cells down. Because of gravity, they will go down and the supernatant plasma can be separated. So collect appropriate volume of donor blood in an anticoagulant like CPDA mixture in a double or triple bag. Store at 2 to 6 degree till process. Place bags in the buckets of refrigerated centrifuge and balance the opposite bags accurately. And centrifuge at a heavy spin of 5 rotations for 5 minutes at 2 to 6 degrees centigrade. Express approximately 3/4 of the plasma into the satellite bag. Double seal and tube will be between there, and immediately it will be sealed and they can remove them. Keep the red blood cells at 2 to 6 degrees centigrade. Now, red cell concentrate quality indicators. It should be having a volume of 250 to 300 ml. So, what you routinely use in your theater, the RBC concentrate or packed red blood cells, the volume should be only 250 to 300 ml. And it should have a hematocrit. These are all the questions the examiners ask you in Viva also. So, what is the volume of red cell concentrate or packed red blood cell you get in your theater? Tomorrow, when you use it, please look at the preparation. Make sure it will be only 300 ml, whereas whole blood will be 450 ml. The hematocrit of this is about 55 to 75%, with a hemoglobin of more than 45 grams per deciliter. But the pH is a little acidic, 6.4 to 7.4, and there is bound to be some hemolysis of 0.8%. And that is the reason why when repeated transfusions are given, iron overload occurs, as we discussed in the last discussion. And it should be sterile and some leukocyte, unless it is a specifically leukocyte reduced, there will be some leukocyte present, which will be should be less than 2 into 109 by units. And when you say it is a leukocyte reduced RBCs, you can remove the leukocyte by again centrifugation and removing what is called the buffy coat. That will come in like a soap bubble above, and you can remove that, or you can filter or wash the red cells with saline, and then freezing and thawing of the red cells. By all these means, you can remove the white cells and produce what is called leukocyte reduced red cells. And preparation of platelet concentrate. How do you do that? You do a random donor platelet prepared from 450 ml of whole blood. So you take the whole blood for random donor platelet, single donor platelet by apheresis. So the procedure is collect it in triple pack system, store at room temperature, For less than 6 hours, within 6 hours, you should do the separation. Place bag in a bucket. I think there are pictures to show that rather than reading them. Then again centrifuge and separate and place platelets at a temperature of 20 to 22 degrees centigrade. They don't require high refrigeration. That is the advantage of platelet. It can be kept at a temperature of 22 to 22 degrees centigrade. 20, what precautions when agitating that before use during storage, which will cause exchange of gases, maintenance of pH is important, reduce formation of platelet aggregate. If pH should never fall below 6.4, that will cause change in the shape. Pseudopore formation will happen and it may release the platelet granules. So beyond 6 hours, if you collect that, may not function properly. What are the quality indicators of platelet? The volume of the bag is only about 45 to 55 ml, very, very small volume. And the platelet count will be more than 55 to 109 units. Residual leukocyte also should be less than that, and residual some red blood cells also may be there, very, very small quantity. It should be very low, and again pH is same like your RTC concentrate, and sterility should be ensured. Then how do you prepare fresh frozen plasma? When you collect the blood as a system, store at 4 degrees, then place the uh, bag in bucket. I think I have pictures for that. During blood collection, the flow should be continuous. More blood you have to maximum take only 450 ml. And during the process, freezing the plasma as soon as possible, maintaining storage temperature. But during when you after freezing, when you want to reuse it, you thaw it, make it every ports of the bag should remain above the water, and within 12 hours it should be kept at 2 to 3 degrees. The quality indicators for fresh frozen plasma, the volume is 180 to 200 ml. So RBC concentrate is maximum 300, platelet 50 ml, and FFP 200 ml. Please remember at least these round numbers. And it may have factor 8 level more than 0.7. It may have some fibrinogen also, and it should be sterile. And the frozen plasma can be thawed at 1 to 6 degrees. Centrifuge and plasma express leaving behind a precipitate, which is known as cryoprecipitate or cryo. This can be both stored subsequently at minus 18 degrees centigrade. So this is how the whole picture, this picture shows how they are all separated. So this is the whole blood. This is called the triple pack or quadruple pack system. So all these bags are connected together. So when you puncture the vein of the patient, the first bag you collect the whole thing, and then this bag is rotated into the centrifuge like this. Then the supernatant plasma comes to this. Then from there you can just seal it off and remove this alone. So this is platelet rich plasma AS1 like that. So all these things can be uh, closed here, sealed here, and then separated. That's the advantage of the model. So in this final picture, if you see, you have separated the red blood cells, you have platelet concentrate, you have fresh frozen plasma, and you have cryo. All these things are interconnected and they can be easily removed. And the apheresis is nothing but donor blood is collected, then the components separated, the target finished, blood components and red blood cells, plasma for pharmaceutical manufacturing. Whatever remaining, you can reinfuse or re-transfer into the patient himself. So in apheresis, you take out the blood, components separated, whatever target you want to achieve or take, you take that. The rest of it you can pump it back into the patient itself. So that is the apheresis technique. So it's a very simple method of remembering and writing the exam. So you can write about the indications. I think I could include that also. When will you choose to use what component? So pure anemia correction or sickle cell, you can go for platelet, factor and blood cells. For conditions like dengue or other bleeding disorders where platelets are drastically reduced, you go for platelet. And conditions like DAC, you go for cryo, which contains more fibrinogen. And for warfarin correction, you go for FFP. Like that, you have to remember. And each one, another important point is PRBC requires grouping and cross matching, whereas most of the others they don't require any cross matching. They can be safely induced because you are removing all the antigen antibodies which are available, so the mismatch transfusion possibility is not there. Okay, so that is what people to remember. Thank you. Any other